Astronomers recently discovered another kind of solar tornado. It's made of a thin stream of charged particles coming from the sun, and it actually reaches down into the Earth's atmosphere, jolting it with electric current many times a day.
Space tornadoes touch down every few hours. They funnel energy down into the Earth's ionosphere, about 100 miles above our heads, actually. And they can carry up to 1 million amps of current.
That's enough current to power 100,000 homes. The supercharged tornadoes are responsible for kickstarting the breathtaking auroras we see in our planet's polar regions. But the twisters themselves are so widely diffused, they are invisible to the naked eye. It's long been known that the auroras are associated with the solar wind. The solar wind is the constant flow of charged particles coming from the sun and blowing toward the Earth.
Scientists had a problem. It turns out that if you calculate the energy stored in the solar wind, you find that it's not large enough to generate the spectacular light show called the aurora borealis. There had to be another source of energy driving the auroras.
That source of energy comes from the Earth's magnetic field. It deflects the solar wind, making the charged particles blow around the planet. On the Earth's dark side, energy from the solar wind gets stored up and then released in bursts by the planet's magnetic field lines.
These lines cross on the dark side of the Earth, and when these lines cross, they rearrange themselves, releasing a burst of energy. And that's the energy of what are called substorms.
The magnetic substorms create lots of turbulence, which generates the rotating motion any tornado needs. That rotation comes from circular whirling eddies, similar to the rings of swirling vapor that show up in the turbulent flow of a wind tunnel on Earth.
And these eddies are the space tornadoes themselves. And about a minute later, after these eddies form, that eddy, that twisting of the magnetic field line, funnels down into Earth's ionosphere, where it's ultimately responsible for the aurora.
The space tornadoes generating Earth's auroras are huge. They form more than 62,000 miles above the planet's surface, taking on a classic funnel cloud shape. Wide at the top, but narrow at the bottom, where they touch the Earth's atmosphere.
Space tornadoes out in Earth's magnetosphere are twice the size of the Earth, about 15,000 miles in diameter.
But when they touch down on the Earth, they're actually quite narrow. So you've got this flowing